Introduction. The Human Technology Revolution. In April 9, 2012, Mark Zuckerberg made a decision that would challenge how the software industry thinks about technology assets. In a weekend negotiation at his Menlo Park home, he agreed to pay $1 billion for Instagram, a photo-sharing app with zero revenue built by just 13 employees. The acquisition shocked the tech world. How could 13 people with simple code be worth more than companies with thousands of engineers and complex architectures? The answer reveals the central insight of modern software development. The most valuable technology in any software organization is the human capability to solve problems collaboratively. Instagram's team created billion-dollar value not despite their small size and simple code, but because of their exceptional human compilation capability. They could process user feedback faster than competitors, transform insights into product changes more efficiently, and adapt to market conditions more quickly than organizations with superior technical resources but inferior human compilation processes. The Human Compiler Insight. Great software teams function as sophisticated problem-solving technologies that transform abstract business requirements into competitive advantage. Like software compilers that transform source code into executable programs, human compilers transform business needs into working solutions, but with far greater sophistication, adaptability, and creative capability. While traditional compilers follow predetermined algorithms, human compilers can handle ambiguous and conflicting requirements, integrate vast contextual information about markets, users, and constraints, invent new optimization strategies for novel problems, learn from each compilation cycle and improve their processes, validate outputs against business value rather than just technical correctness. This human compilation capability explains why small, effective teams consistently outperform large engineering organizations. It's why companies pay billions to acquire teams rather than trying to replicate their technical outputs. It's why the acqui-hire market values proven teams at $1 to $2 million per engineer. The technology asset hierarchy. Understanding teams as technology requires rethinking the asset hierarchy in software organizations. Primary technology asset, human compilation capability. Teams that can transform any requirements into effective solutions, adapt to any technical change, and leverage any available technology to solve problems. Secondary technology assets, code and infrastructure. Technical implementations that support human compilation processes. Valuable when they enable team effectiveness, liability when they constrain adaptation or consume resources without enabling better human compilation. Tertiary technology assets, tools and platforms. Specific technologies that amplify human compilation capability. Their value derives entirely from how effectively teams can use them to solve problems and create business value. This hierarchy inverts traditional thinking that treats code as primary asset and teams as resources. In reality, teams are the technology that makes all other technology valuable. Code without effective teams to maintain and evolve it becomes technical debt. Infrastructure without teams to leverage it becomes expensive overhead. Tools without teams to master them become organizational complexity. The competitive advantage framework, organizations that recognize teams as their primary technology asset, create competitive advantages through superior human compilation processes. Adaptation speed. Human compilers can respond to changing requirements, new technologies, and market shifts faster than any technical system. They can learn new technologies, abandon obsolete approaches, and invent solutions for novel problems. Creative problem solving. Human compilers can solve problems that pure technical approaches cannot handle. Ambiguous requirements, conflicting constraints, innovative user experiences, business model innovation. Learning and evolution. Human compilers improve through experience, building better problem-solving capabilities with each challenge. Unlike code that degrades over time, human compilation processes appreciate through accumulated knowledge and refined collaboration patterns. Technology leverage. The best human compilers can leverage any available technology, from traditional development tools to artificial intelligence, to amplify their problem-solving capability. They're not dependent on specific technical stacks but can adapt to and master whatever technologies provide advantage. The revolution ahead. The organizations that recognize and optimize their human technology will define the future of software development. While their competitors debate technical architectures and accumulate technical debt, these companies will build adaptive capabilities that can leverage any technology to solve any problem. The human compiler revolution represents the next evolution of software development. From technology-dependent organizations to technology-adaptive organizations powered by human compilation capabilities that make every other technology more valuable. Table of Contents. Introduction: The Human Technology Revolution. Part 1. The Human Technology Paradigm. Chapter 1. Teams as Technology Recognizing Your Most Important Technology Asset. The Instagram lesson, 1 billion for human compilation capability, why human compilers outperform technical systems, the technology asset hierarchy, inversion technical excellence as team capability expression. Chapter 2. The Economics of Human Technology. Understanding true technology investment returns. Code as infrastructure, necessary but depreciating teams as technology. Appreciating through learning, the real cost of technical debt, versus human capability, investment case studies, human compilation success, versus technical complexity failure. Chapter 3. The Human Compiler Architecture. How teams process requirements into competitive advantage, human compilation versus technical compilation capabilities. The 5 processes of human compilation. Conway's Law. Team architecture drives technical architecture. Amazon's Human Compiler. Scaling Model. Part 2. Building Human Compilation Systems. Chapter 4. Measuring Human Technology Performance KPIs for your most important technology, human compilation efficiency. Metrics Team. Technology. Health indicators. Value output. Measurement for human compilers. ROI. Calculations for human technology investment. Chapter 5. The Human Multiplication Effect. Why team technology capabilities compound Google's project. Aristotle, Human Compiler Optimization Research. The mathematics of team technology performance. Collaborative capability amplification. Why human compilers scale exponentially. Chapter 6. Building human compilation capability. Developing your technology platform. Netflix's human technology. Density strategy. Hiring for human compilation capability. Developing team technology through collaborative technical practices, knowledge, networks, versus documentation systems. Chapter 7. Scaling human technology, maintaining compilation efficiency during growth. Amazon's Human Compiler, architecture principles. Technical infrastructure supporting human technology. Preserving compilation capability during scaling organizational architecture for human technology optimization. Chapter 8. The Learning Technology Advantage. How human technology appreciates through experience, why human compilers improve while code degrades knowledge. Accumulation in human technology systems. Institutional memory as technology asset building. Self-improving human technology. Part 3. Optimizing human technology. Chapter 9. Human technology operations, running your most important technology platform. Operational metrics for human compilation systems. Performance. Tuning for team technology monitoring and alerting for human compilers. Capacity planning for human technology scaling. Chapter 10. Human technology transformation, upgrading your technology platform. LinkedIn's Human Technology Platform. Rebuild migration strategies from technical-centric to human-centric. Change management for technology. Platform evolution. Implementation. Roadmap for human technology. Optimization. Chapter 11. Leading human technology. Managing your most important technology asset. Technical leadership for human technology platforms. Overcoming resistance to human technology investment, building business cases for human compilation systems. Communication frameworks for human technology value. Chapter 12. The future of human technology, sustaining competitive advantage through human compilation. AI as amplifier for human technology capability. Human technology in rapidly changing environments. Organizations as human technology platforms. The competitive advantage of superior human compilation. Conclusion. The Human Technology Revolution. Appendices: A. Human Compiler Assessment Framework. B. Human Technology Performance Metrics. C. Implementation Checklist for Human Technology. D. Resources for Human Technology Development. Part 1. The Human Technology Paradigm. Chapter 1. Teams as Technology. The most profound insight in modern software development is recognizing teams as technology platforms, rather than resources that use technology. This reconceptualization transforms every aspect of how we think about technology investment, competitive advantage, and organizational capability. Teams are sophisticated technology systems capable of processing complex inputs, adapting to changing conditions, and generating value-creating outputs in ways that no software system can match. Understanding teams as technology, your most important technology, enables optimization strategies that create sustainable competitive advantages. The Instagram lesson, 1 billion for human compilation capability. Instagram's acquisition demonstrates the economic value of human technology. Facebook paid $1 billion not for Instagram's codebase, which was built on standard technologies like Django and PostgreSQL, but for their team's proven human compilation capability. Kevin Systrom and Mike Krieger's 13-person team had demonstrated exceptional ability to transform user feedback into product improvements rapidly. When they realized users only engaged with photo features in their original Bourbon app, they could pivot the entire product in weeks. This wasn't just good decision-making, it was superior human compilation processing. Human compilation speed. Instagram's team could process user signals, evaluate product alternatives, and implement changes faster than competitors with larger engineering organizations and more sophisticated technical infrastructure. Adaptive capability. When market conditions changed or user preferences evolved, Instagram's human compilers could adapt their entire product strategy and technical implementation rapidly. Creative problem solving. The team invented solutions, like simplified photo filters inspired by Polaroid cameras, that combine technical possibility with user psychology in ways that pure technical analysis couldn't achieve. Learning integration. Each user interaction taught the team something that improved their human compilation processes, making them more effective at transforming future requirements into user value. Facebook's acquisition paid for this human technology capability, not the secondary technical assets, code, infrastructure, that the team had created using their human compilation processes. Why human compilers outperform technical systems. Human compilation capability surpasses technical compilation in every dimension that matters for business success. Input processing. Technical compilers require precise, unambiguous inputs. Human compilers excel at interpreting vague business requirements, conflicting stakeholder needs, and incomplete user feedback. They can ask clarifying questions, challenge assumptions, and transform unclear requirements into specific problems worth solving. Context integration. Technical compilers operate in isolation. Human compilers integrate massive amounts of contextual information, market conditions, competitive landscape, organizational constraints, user behavior patterns, technical limitations. This context integration enables optimization decisions that technical systems cannot make. Error handling. Technical compilers halt execution when encountering errors. Human compilers can work around incomplete requirements, adapt to changing constraints, and find creative solutions when standard approaches fail. They continue processing even when inputs are imperfect or contradictory. Output. Quality. Technical compilers verify syntactic correctness. Human compilers evaluate business value, user satisfaction, competitive advantage, and long-term strategic fit. They can iterate on outputs until achieving business objectives rather than just technical specifications. Learning integration. Technical compilers repeat the same processes indefinitely. Human compilers improve their processing through experience, learning from successful and failed compilations, and adapting their approaches based on outcome quality and environmental changes. Error recovery. Technical compilers halt execution on encountering errors. Human compilers can recover from problems creatively, find workarounds for impossible constraints, and continue processing even when facing unprecedented challenges. The 5 processes of human compilation. Human compilers transform business requirements into competitive advantage through 5 integrated processes that work together to create value. 1. Contextual input. Processing. Human compilers interpret business requirements within complex contexts, market conditions, competitive landscape, organizational constraints, user behavior patterns, technical limitations. This contextual processing enables solutions that address not just stated requirements, but underlying business needs. 2. Creative synthesis. Human compilers combine technical possibilities with business requirements creatively, inventing solutions that stakeholders didn't envision initially. This synthesis capability enables innovation and competitive differentiation that pure technical implementation cannot achieve. 3. Adaptive optimization. Human compilers can modify their processing strategies as they learn more about problems and constraints. They optimize for changing criteria, adjust approaches based on new information, and evolve solutions as understanding deepens. 4. Collaborative validation. Human compilers validate outputs through multiple perspectives: technical feasibility, business value, user experience, competitive positioning. This multidimensional validation ensures solutions create actual value rather than just meeting technical specifications. 5. Learning integration. Human compilers capture insights from each compilation cycle, building pattern recognition, refining processes, and improving future compilation capability. This learning integration creates compound improvements over time. Conway's law: team architecture drives technical architecture. Melvin Conway's observation that system designs mirror organizational communication structures reveals the fundamental relationship between human technology architecture and technical infrastructure. Team architecture as primary. The structure, communication patterns, and coordination mechanisms of human compilers determine the characteristics of technical systems they create. Technical architecture emerges from human compilation processes. Technical infrastructure as secondary. Code architecture, service boundaries, and system interfaces reflect the collaboration patterns and problem-solving approaches of the teams that created them. Technical design serves human compilation processes. Co-evolution requirement: as human compilation processes evolve, technical infrastructure must evolve to support new patterns. As technical infrastructure changes, human compilation processes must adapt to leverage new capabilities effectively. Optimization priority. Organizations should optimize human compiler architecture first, then align technical infrastructure to support optimal human compilation patterns, rather than forcing teams to adapt to predetermined technical constraints. Amazon's human compiler scaling model. Amazon's transformation demonstrates how to scale human compilation capability while maintaining efficiency and innovation capacity. 2 Pizza. Human compilers. Teams of 5 and 8 people optimize human compilation efficiency by minimizing coordination overhead while maintaining sufficient processing power for complex problems. Single-threaded processing. Each human compiler focuses on specific business capabilities, eliminating context switching and enabling deep expertise development in problem domains. Interface-based coordination. Human compilers coordinate through well-defined interfaces, service contracts, API specifications, that enable parallel processing without coordination overhead. Autonomous operation. Human compilers operate independently with authority to make decisions within their domains, enabling rapid processing without approval delays or hierarchical bottlenecks. Technical infrastructure support. Amazon invested heavily in technical infrastructure, monitoring, deployment automation, service discovery, that amplifies human compilation capability rather than replacing it. The result? Hundreds of human compilers operating in parallel, each optimized for specific problem domains, creating competitive advantages through superior collective problem-solving capability that competitors with traditional organizational models cannot replicate. Part 2. Building human compilation systems. Chapter 4. Measuring human technology performance. Optimizing human compilation requires measurement systems that track processing efficiency, output quality, and capability development, rather than traditional software metrics that measure technical infrastructure performance. Human compilation efficiency metrics. Effective measurement focuses on how efficiently teams transform requirements into business value.